Okay, here we see the demo set up, and what we're going to be doing today is just learning how to wire up various electrical motors. I'm not going to do any mechanisms today, I'm just showing you how to wire them up. And I'll show you who the stars of our show is. Okay, we've got three motors. This motor here, that is an AC motor, meaning alternating current. And it's the type of motor that just plugs right into the wall. And here's another motor. This is a DC, and you cannot plug it into the wall. You need a power supply. There is another DC motor, and there's not always a way to tell. Sometimes you need to ask.
But most motors will have a label on them, and here are the symbols for alternating current and direct current.
And on each one of these I actually put a leaf just so you can see what happens when they move. Next we have power supply. You can all recognize that. That's just kind of a ordinary plug that goes into a wall socket. So that would be an AC plug where you get alternating current. And here, this is just one of your regular adapters. That's a DC power supply, and it plugs into the wall. It takes AC and it converts it into DC, and it puts out a different level of voltage. And here is another DC power supply. This one's a little bit different than the others. It also gives direct current, but this is a variable one. It's got this knob on it that you can actually adjust the voltage to make things go faster and slower.
And whenever working with this type of setup or demo, you need a power bar.
There's a couple of other things we've got, and I'll explain these as we go. That's a relay, and a relay is like an electric switch. It has a very small motor in it, and you plug that in, and then it actually flicks a switch. And here we have two limit switches. You can see that they have three tabs on them. One is the common, one is the normally open, and one is the normally closed. Now I'm going to show you two ways of connecting wires together once you've kind of cut them. So the first thing I'm going to do is just take one of these wires here. So with this one, this is a pair of wire strippers, and you can see right here it actually has a little thing for cutting wire. So you just snip it off like this, and then I'm going to reconnect it. First using a Marette. So what you have to do is you have to insert the wire actually into one of the grooves that you see there in the wire snipper. Just insert it in there. It takes a bit of practice to know which one is which. I know it's going to be the larger one, so you just squeeze on it and you pull the plastic covering off. And then we do that with this other one, the same thing. And then what you do is you take the two wires and you just put them together and you twist them clockwise, just once or twice. And then you take the Marette and you insert it on there, and you just keep twisting until the two wires going in begin to twist themselves. Okay, that's one way of connecting wires. Now another way, and again you will need to strip the wires. I'm going to just cut them fresh again and strip new ones. So, and this time you strip a little bit less off. And then you have these two tabs. One is just kind of a prong and the other is a slot, so you just fit them together. Okay, I'll just take them apart again. So then what you need to do, just twist the wire slightly and then push it into the back of this. There's a hole, and you push it in until it goes all the way as far as it can go. And then with the vice grips, you squish it flat. And really flatten it well so that it can't come off. So there you can have a bit of a look at what it looks like. On the other wire, you put the other one, and you squish it flat. So then you just reconnect them again. So these are really good for if, let's say, you've got a big project that you have to take apart and put back together and take apart and put back together again. And it really kind of makes it a lot quicker to connect everything. And then what you do is, with all of your connections, if you think they're fairly permanent, particularly with the morettes, then you can wrap tape around it. But only do that once you're certain you've got it.
And then also where
These tab connectors are connected. It's good to put a bit of electrical tape on there. Okay, but that you do after you've kind of set everything up. So with every
electrical circuit,
you've got two wires. We'll call one of them the hot wire and one of them the neutral. And that's kind of how it works with AC.
and with DC you have the negative and the positive wires. Every circuit essentially needs a power supply, which could be AC or DC, and the load, which could be a motor, a light bulb, or anything that uses the electricity. The electrical path begins with the power supply, with the electricity traveling through one wire, through the load where it is used, and through the other wire where it returns to the power supply, completing the circuit. With alternating current, the direction of the electrical flow switches back and forth very rapidly between 50 and 60 times per second. With a DC power supply, the path of the electricity goes in one direction, which makes it easier to control the direction that the motor turns or the speed of the motor. If you reverse the polarity of the connections with the motor, the direction of the electricity will be reversed. So that's how you create a circuit.
And you have to have something called the load. And the load is actually the thing that uses up the electricity. So you have to complete that circuit in order for the motor to work. If you just connect the two wires together, you're going to create something called a short circuit. And what will happen with the short circuit is it just simply, it'll shut off all your breakers or cause a house fire. Okay. So now what you need to do is you need to actually power the motors themselves. So we're going to start with the AC motor, again alternating current, and essentially for today's purposes anyways, you always just plug them in and they go. And so this has an on-off switch, but I'll turn it on just to see what happens. So as soon as you plug it in, it goes. Now, you can actually use the switch here to turn it on and off. The DC motors need a different power supply. They need something called direct current because the electricity just goes in one direction. So I've got here a DC power supply. I'll turn this off. The DC power supply plugs into the AC and it turns it into DC and it changes it from 110 volts to around 12 volts. And so I've just got these connectors here, and always make sure you unplug things before you connect things up. So I'll just turn this now and you can see it with the power supply on. So then you plug it in and then you can turn it on. Now I can take this power supply off first and then I'll plug it into this one, and then I'm going to attach the variable power supply and show you what you can do differently with that. Now we'll attach this power supply to
the other DC motor.
And you can watch this one go now. So I'm plugging it in. I don't know if you can see it. Then I'll turn it on. Now, you make note of the direction. I'll turn it on again. And it's turning counterclockwise, and that's important to remember. Okay, here we go with the variable power supply. And what you've got here, you've got the on-off switch, you've got the red terminal and the black terminal. And the red connector is the positive and the black is the negative. And then here you've got a little knob where you can change the variable speed. And so what I've done on here, you can see these wires. If you look at a close-up, what I've done is I've tied a knot in one of them, and the knot is actually the positive. And it's a little bit arbitrary which wire you use, but when you actually hook everything up, you want to know when you're working with your positive and negative. You could put a piece of tape around it, you could paint it red. I just know that that's the positive and it's connected to the red terminal. And then here are the two wires that connect to the DC motor there. And one of them you'll see that I actually put on. That's where it's arbitrary. I've put the positive right there and the negative on the other one. And that's a way where you can actually test other adapters if you know which way, if you choose which one is a positive and the rotation of the motor and which one's the negative. Because that's one of the beautiful things about DC motors is when you reverse the polarity, you can actually reverse the direction of the motor. And when you turn up the voltage, you actually turn up the speed. So I'm just going to connect these here. Just put them together. You push it in there. And this one you also push in. So it's connected. So again, this is the adjuster. You turn it on here, and you notice it's going the same direction. It's going counterclockwise. If you want to adjust it, you could turn the voltage down. It will go slower. And it has a direct relationship. Let's say you have 10 volts, it will go one speed, and if you do 20 volts, it'll go twice as fast. Now we'll turn it up. Okay, now I'm going to reverse the polarity. Remember that I had this arbitrarily marked one as a positive and the loop in this wire also as a positive. And I'm going to switch the two wires around. So I'll put the negative on the positive. And I'll put the positive on the negative. Now you're going to see it goes in the opposite direction. Then you can speed it up. And slow it down. So now I'm going to show you how a switch actually works. So we're going to go back to the AC motor, the one right here. What I'm going to do is I'm going to take the wire and I'm going to cut it. Now, you've noticed that I have unplugged it, and if you ever cut a wire, you have to unplug it, otherwise you can cause a short circuit. So I'm just going to do it wherever it looks like a likely place, and I'm going to show you in a way how a switch really works. So I'm going to cut it right here. And then I'm going to strip the two wires. So you see these two bare wires. Now if I plug it in, the motor won't go because I've interrupted it right here. Okay, so now I've plugged it in. And I'm going to turn it on, and you notice that it doesn't work. And that's because I've interrupted one of the wires along the circuit. Now, all I have to do is touch them together, and that turns the motor off and on. Now that's not a very good way of doing it though, so what you need to do is you need to connect it to a switch. And what we've got here is a micro switch, and you're going to see that it has 3 prongs. The bottom prong is the common, so one of the wires is always going to go through the common. And then on the bottom one here, you've got normally open, and the one on the top normally closed. So what you need to do is, inside the switch, it essentially does exactly what I'm doing there. It just closes the circuit. So what you need to do is, you need to connect these wires to these tabs here. The connectors will be very much like this, except we need one that's just a little bit smaller. So what you need to do with these connectors is you have to find one that actually fits. You have to make sure they're the correct size. So these 2 fit. And then you do the same thing again with the 2 pieces of wire, is you just twist them slightly. Insert these as far as they go. And it's good if a little bit of wire is sticking out right there. That means it's gone all the way through. And then you squeeze these tight again. And then what you do is you attach these connectors, and it doesn't matter which one you use first. You connect these to the switch. So one has to go on the common, and what we're going to start with, here's the other one. We're going to start with normally open. Normally open means normally off. So here you can get a good look of them. Okay, and then you just have to flick the switch off and on. And you see, because it's normally open, meaning normally off, as soon as you hit the switch, it turns on. Now, if you connect it to the normally closed, which means normally on, it'll turn on until you hit the switch, and that will turn it off. So let's say that's really handy if you have something moving along and you need it to stop when it hits the switch. That's what these limit switches are for. See, now it turns on, and you hit the switch and it turns off. So here you have the relay, and you can see that it's got 3 banks, 3 rows of these tabs that go in one direction, and the bottom one here, that is common, and then you have normally open and normally closed, just like on the switch. And you attach whatever you're trying to turn on and off the same way, except rather than a lever, it has a small motor on the inside, so when you turn the relay on, it flicks a switch, and that way you can use a very, very tiny switch to turn on something much more powerful. Or you can use an AC source to turn on a DC mechanism. So what you do is you just connect 2 wires that come from the AC power supply to these tabs. Then you can plug it in and see what happens. So now watch it very carefully when I turn it on. So whenever I plug this relay in, what will happen is, once I connect this to the relay and run the power through it, by turning the relay on, I will be able to switch the mechanism on and off. So where I had that switch, where I put this switch in, I'm going to take those 2 tabs off, and I'm going to then put them onto the relay on the normally open and the common. So you can see I've connected them on the same 2 wires that were originally on this switch here. So you'll see the motor is plugged in, and then when I turn the relay on, it'll turn the motor on. So here you can see the whole setup. There I've got the relay, and the relay is plugged into the power supply. And here is this motor. It's plugged in, and where it's interrupted, rather than having the switch, it goes through the relay. So now when I turn the relay on, you'll see that the motor turns on, and then I'll explain why you would want to do that. Well, for one thing, what you could do is you could turn on two different mechanisms at the same time, or you could turn one on and one off. So, and they can be of a different type of electricity, like you can have one that is AC and one is DC. And what I'm going to do is I'm going to connect both of them to that relay, because they've got the three sets of tabs, so I could actually turn three things on and off. So what I'm going to do is I'm now going to wire up the other DC motor, and you'll be able to see that when I turn it on and off, one turns on and one turns off. And then I'm going to show you how you can use a different type of switch to turn everything on.
So now I will take these two wires from the DC motor with connectors on them and attach them to the common and the normally closed tabs on the relay.
And you can see I've got one connected to the normally closed. And then one of the leads from the small DC motor I connected back to the power supply. You can see it here. I will connect these two leads to these two wires. So here we go now. I'll take the two leads that would normally connect together, and I will connect them together. And then I'll just show you the circuit. So there is the relay that has where the switch would normally go from both the AC and the DC motors. It's been interrupted from their power supply. And so now when we turn the relay on, or when we turn everything on, one will turn on and then the other will turn on, depending if I switch them off and on. Now, I could put a switch in here, but I'm going to show you another type of switch. I'm first going to show you how this works, and then we will add one more switch to it. So I'm going to actually unplug the relay, and I'll just plug it in and unplug it, and plug it in and unplug it, very much like I'm doing a switch. So you'll see how one turns on and the other turns off. Now, as soon as I turn it on, actually one of the two is going to go, and automatically, because the relay is actually set to one of them is normally closed and one of them is normally open. So I'm going to unplug it first. I'll turn it on. You see that one goes. And as soon as I plug it in, it'll switch. Until I turn the entire power supply off. Now, you could put other relays and other switches, but that just shows you how a relay can work, turning one thing on and one thing off, and using two different types of electricity, again, one AC and one DC. So what I'm going to do here is I'm going to cut one of the leads that turns on the relay, and I'm then going to I'm first going to strip them, and then I'm going to use a magic switch. So I'll need to connect two wires to that'll then connect to another switch. So you can see now I've put two connectors on, and I'm going to connect them to this switch right here. So you can see that the relay here, the wire that is plugged into the plug, has been interrupted by the magic switch, and you can see it connects to it. Okay, now I'm just going to turn it on, and you'll see all I have to do is wave my hand over and it turns them on and off. Now when I turn it on, one will go on and one will be off, and then when I wave my hand over, they'll reverse. So what I have here is a magnet, and that's just a little magnetic switch. And it's got a googly eye on it. So now what I've done is I've hooked it up to a motion sensor. There's the motion sensor. And just when I move my hand in front, it'll So the motion sensor does more or less what the magnet did, but except one thing I've done is I've connected the relay directly to the motion sensor, so it doesn't really work as a switch so much as it actually provides the electricity for the relay. And I will diagram that for you so you can see what the wiring looks like.